So we're going to be in section 5.2. We are continuing on talking about exponent rules. We spent the first part of section 5.1 talking about the product rule, the power rules, and then I even gave you my 4 steps for simplifying exponential expressions. And so we're going to continue with that today. And so as we continue on, just want to quickly mention the product rule again. We're not going to work through these problems because we've already done these. The product rule says that if you are multiplying and you have the same base, then we're going to keep that base and we're going to add exponents. And so the m and n get added. Okay. Again, we saw that. We've already looked at several examples with that from section 5.1. Section 5.2 deals with the power rules. And so the first one we said we're going to refer to as a power to a power, because if you have an exponent and that's raised to another exponent, then this rule says that we'll keep our base and we'll multiply those exponents. And again, we've seen that in multiple problems already. Then the next one, power rule B, we said works like a distributive property because this power of m that is outside the parentheses goes to both of those bases, the A and the B. And so it works like a distributive property. It is not the distributive property, but it sort of works like that. And then the same thing with power rule C, it sort of works the same way, but across a fraction, where it says this exponent outside the parentheses goes to the top, and it also goes to the bottom. And so we use that in some problems where we started seeing these being combined in the last section. So now we're going to move on and talk about some other exponent rules. And so our first one is what we call the zero exponent rule. And this is one that is pretty self-explanatory. It's pretty easy. It's not a lot to it. Basically, it says that if you raise anything to the 0 power, you get 1. That's it. That's all it says. If you raise any number to the 0 power, or any base to the 0 power, you get 1. So, let's look at the first example. If we take 29 to the 0 power, well, our rule says that anything to the 0 power has to be 1. Pretty easy. If you take negative 29 and raise it to the 0 power, you should get 1. And then if you look at the next one, if you take a negative 29 to the 0 power, what is that? And some of you are saying 1. No, it's not 1. This one actually is negative 1. And the reason is because this 29 is your base. The 29 to the 0 power is 1, but then it's a negative 1. So that's where the negative 1 comes from. So again, that base to the 0 power is 1. And then on the next one, 8 to the 0 power is 1. Minus 15 to the 0 power, which is also 1. 1 minus 1 we know is 0. Okay? So, that rule hopefully is pretty easy. Now, the first time that I ever heard this rule, I think I was in high school at some point, and my teacher told me what I've told you. Anything raised to the 0 power is 1. And so, most of you, I feel like, probably know me pretty well at this point. You know that I probably wanted to know why. And so my hand goes up, and I ask the question, why? And my teacher never really could give me a good answer. She kind of tried to skirt around the question and just say that it had to be 1. And I said, no, but why? Why is it 1? Because in my mind, I thought it should be 0. Now, I was incorrect. She was right. But I wanted to know why. And after kind of pushing, and I probably was more of a smart aleck than I should have been, she eventually just said, well, that's just the way it is. And I always sort of resented the fact that she couldn't tell me why it was 1 instead of 0. So I don't want to be that teacher. So I'm going to very briefly show you why it's 0 instead of 1. So let's start with this. If I ask you, what does 2 to the third power literally mean? You would tell me, well, it means 2 times 2 times 2. So the 3 in this case tells us how many times 2 is being multiplied. And I think everybody would probably agree that's true. And so if I gave you this 2 to the 0 power, well, what does the 0 tell us? Well, it tells us how many times 2 is being multiplied. Okay, now think about this. This 2 to the third power, I believe you would agree that 1 times 2 to the third is still 2 times 2 times 2, which in this case ends up being 8. Well, if you would agree that 1 times 2 to the third is that, then this should also be true, that 1 times this 2 to the 0 should also be a true statement. And so what that 0 means is that there are no 2's being multiplied. It does not mean there is a 0. A 0 is a number, right? It does not mean there is 0. I've told you now a couple of times throughout this class that you've been lied to all your life, and that people have always told you 0 and nothing are the same. And that is not always true. Because in this case, it is 1 times nothing else. There is nothing else being multiplied, because this 2 to the 0 power says there are 0 2's being multiplied. Not that it's 2 times 0, or not that it's 1 times 0, but it's 1 times nothing else. And so if 1's not being multiplied by anything, it's just 1. And so that is a very brief explanation for why this is 1 instead of 0. As a student, when I thought 0, I think what I probably did was I was thinking about multiplying 2 times 0, and that's not what it says. Okay? So you got to be really careful with the 0 exponent. Anything raised to the 0 power is always going to be 1. Okay? If there's any questions about that, feel free to let me know. I'll be glad to answer any of those. Now, on our next slide here, if we were doing this in class, I would ask you to take out a sheet of paper. You can do this if you want to. I'm going to kind of walk you through it, but you don't have to. I think it's a fun little activity that you can do. So if you want to do this, pause the video for a second, go grab a sheet of paper. Once you've grabbed your sheet of paper, first thing I want you to do is we're going to fold the paper and make sections out of it. So before we fold it, how many sections of paper do you have? I think you would all look at it and say, well, there's only one section. Okay? Now, fold that paper in half. You can do hamburger style, hot dog style, it doesn't matter. Just fold it in half. Pause the video if you need to. Once you get it folded, open it back up. How many sections do you have? Well, you should say you have 2 sections. Now, with it being folded that first time, fold it a second time. Pause the video if you need to do this. When you get it folded the second time, open it back up, and how many sections do you have? And so you'll see that you have 4. Then with it folded the second time, fold it in half again. Now, at this point in class, I would ask you, how many sections are you going to have? And there's always 2 answers I get. I get 6 and I get 8. Okay? So I encourage you, fold it that third time, open it back up, and you'll see that you have 8 sections. Now, with it folded the third time, pause the video and fold it a 4th time. When you open it back up the 4th time, again, I would ask in class how many are you going to have, and I always have people say 12, and I always have people say 16. And in this case, 16 is the right answer. And then I would encourage you, so we folded it 1, 2, 3, 4 times. For kicks, let's fold it one more time. So again, pause the video to fold it that 5th time if you need to. And when you open it back up, again, I always ask how many sections are you going to have, and before people can get it unfolded, I always hear 2 answers. I hear 24 and I hear 32. And the correct answer is 32. Now, what you have done when you do this is you have created a pattern for what happens when you take the number 2 and raise it to an exponent. And the exponent is the number of folds that you had. So when you had 0 folds, you had one section of paper. When you had 1 fold, you had 2 sections. When you had 2 folds, you had 4 sections, and so on. All the way down to 2 to the 5th, which is 32. Now, my question for you is, what's the pattern? Again, if you need to pause it and think about that, go for it. You should notice that the pattern is that each number is being doubled, right? If you multiply each of those numbers by 2, you get the next number, okay? So if we were to think about that pattern going backwards. So look, before we do that, if we had 2 to the 6th power, or if we were to make a 6th fold, how many sections would we have had? Well, you probably know at this point we would have had 64. And 2 to the 6th is 64. And so what's our pattern if you go backwards? Hopefully you look at that and say, well, you're cutting every number in half, right? You're dividing by 2. Because half of 64 is 32, and half of 32 is 16, and half of 16 is 8, and half of 8 is 4, and half of 4 is 2, and half of 2 is 1. And so the reason that I want us to do this is because, number one, it helps us to see that this 2 to the 0 power has to be 1. Because if you do this pattern, 2 to the 0 power being 1 falls perfectly within this. Maybe helps you be convinced that any number to the 0 power is 1. You could do the same type of pattern with 3 to a power, 4 to a power, 5 to a power. Pick your favorite number to a power, and you would see a similar type pattern where every time this number to the 0 power is always 1. And so again, maybe helps you be convinced of that. The other reason I wanted you to do this is because it leads us into our next exponent rule. So what if you were to continue this pattern? So we went to the 6th, to the 5th, to the 4th, to the 3rd, to the 2nd, to the 1st, to the 0. What do you think 2 to the negative 1st would be? And again, pause the video for a minute and think about that. And I always have 2 answers that people come up with. People always say -1 or -2. And both of those are incorrect. And so what we end up doing is we think about, okay, what does this pattern say? Well, if we go backwards, we see that this pattern is cutting every number in half. So half of 32 was 16, and half of that was 8, half of that's 4, and half of that's 2, and half of that's 1. Well, continuing that pattern, what's half of 1? So maybe said 0.5 or 1/2. That's true. So let's continue that. What would 2 to the negative 2nd be? Some of you are saying it probably. What is half of a half? You should get a 4th. I'll tell you a funny story. About half of a half in a minute. If we continue that, what is 2 to the negative 3rd? Hopefully you say, oh, well, that's 1/8. Half of a 4th is an 1/8. So let me go back to the half of a half for a second. When we're thinking about this, if you're thinking about cutting a half in half, if you had 1 foot, okay, think about that. If you cut it in half, you have a half a foot, right? If you cut that in half, what do you have? Well, you have a 1/4 of a foot, right? And so if you were to cut that 1/4 in half, you're going to have an 1/8. If you were to cut that 1/8 in half, you would have a 16th. If you were to cut the 16th in half, you would have a 32nd. And you could continue that pattern. Now, before I move on, let me tell you the funny story about half of a half. I was in class one semester. Same guy that told me nobody would do the 3 to the 5th is 15. Okay, if you remember in that first video from section 5.1, I was talking about that and talking about this guy that was very emphatic. No, nobody's going to do that. Nobody's going to do that. And then that guy did. Well, this same guy is in this class, again, in this chapter, and I'm going through and I've asked the class, and I'm standing in front of the class and, hold my hands up about a foot length, and I said, okay, if you take 1 foot and you cut it in half, what do you have? And I moved my hand, and everybody said half a foot. And I said, okay, if you have half of that, what do you have? And I promise you, without cracking a smile or anything, the guy looked up and he goes, some toes? And that's humorous for us to think about. That's not the kind of foot we're talking about. We're talking about a 12-inch foot, cutting it in half, and you have 6 inches, and you cut that in half, and you have 3 inches, and so on. But it was really funny at the time, and everybody laughed, and it was a good time, because he thought we were talking about having some toes. So, with that in mind, again, I like to share that little story with you. But if you think about this pattern, we begin to see this negative exponent come up. And this becomes an issue for some people. They go, wait a minute, I've never seen a negative exponent before. What do I do? And so that leads us in, leads us into this next exponent rule. And this is the basic negative exponent rule that we're going to have. You need to make sure you have this written down somewhere in your notes. It says that if you take a base and you raise it to a negative exponent, the way we make the exponent positive is to put that base and its exponent underneath 1. Make it 1 over that base and the positive exponent. So here's how we're going to think about this. If you were to think about this a to the negative power as a fraction, being over 1, all we're going to do is we're going to take that base and its negative exponent and we're going to send it to the bottom. And when you do, on the top, since there's nothing left, it's an understood 1. That's where this 1 comes from. And then on the bottom now, we have this a to the positive power. And notice that the power of the exponent changes, and that's all. The number sign does not change. It doesn't become a negative number. And so those of you that, when I ask what was 2 to the negative first, if you said -1 or -2, once you understand what this rule says, that really makes no sense, because moving this base and its exponent to the bottom only changes the sign on the exponent. Okay, so be careful with that. That is something that can be somewhat confusing. So, let's look at each of these, and then we'll stop this video and follow up talking about negative exponents more in a few minutes. So our directions say write with positive exponents. I am not worried about trying to simplify it completely or evaluating. What I am worried about is making sure we get the right exponent. Okay, and so if we're going to take 6 to the negative 5th and write it as a positive exponent, we're going to think about this as being over 1. And to make that become a positive exponent, we're going to take that base and its negative exponent and we're going to send it to the bottom. And so when we do, on the top, there's a 1 left. And now on the bottom, we have 6 to the positive 5th power. And so there is our answer. So not a lot to it if you just understand that moving the base and its negative exponent is going to change that sign. So look at the next one. If we want to take 2x, that whole quantity raised to the negative 4th power, and we want to make that a positive exponent, well, we can, again, think about this as being over 1, and then send that base and its negative exponent to the bottom. What's left on top is a 1. What's on bottom is now 2x to the positive 4th power. So there's that answer. Now, look at the next one here. Notice this one starts out as a negative number. In the very beginning, it's a negative number. When we finish, it better still be a negative number. And so if we approach this one like we've done the others and think about it as part of a fraction, what is the base getting the negative exponent? Well, I hope you say it's p and p only. -7 does not have the power. Remember, we said the base is whatever's directly in front of the exponent. And so that p to the 4th power, or p to the negative 4th power, is the base with its negative exponent. So we're going to take it and send it to the bottom. But what happens to the negative 7? Well, it's still on top. It didn't move. It stays on the top. But now on the bottom we have p to the 4th power. And so there's that answer. If you have any questions about any of these, feel free to email me and let me know. I can do a Zoom session with you and we'll talk about it. If you look at the next one though, now we have a negative exponent on the bottom. So how do we make it positive? Well, I hope it makes sense that if you can take a base and its positive exponent and move it to the bottom, a base and its negative exponent and move it to the bottom and make it positive, well, then you could also take a base and its negative exponent and move it to the top and make it positive. And so when you do that, we have, in this case, z to the 6th. And it's technically over 1 because there's nothing left on bottom but a 1. But that 1 on bottom is not needed. If the 1 is on top, like in the first two examples, it is needed. But in this case, it's not. And then if you look at the last one, again, think about it as a fraction where it's currently over 1. And we want to take the base with the negative exponent and move it to the opposite place. Move it to the bottom in this case. And so this q to the negative 5th is going to go to the bottom. And so what's on top? Well, still p to the 2nd, or p squared. And on bottom we have q to the 5th. So here's the key to this. To make your exponents be positive, you take your base and that negative exponent and move it to the opposite place. If it's on the bottom